IRC method of design of flexible pavements. In that design traffic, the method considered traffic uh, in terms of the cumulative members of the standard axle, that is 8160 kg, to be carried by pavement during the design life. This requires the following information like initial traffic in terms of CVPD, traffic growth rate during the design life in number of years, vehicle damage factor VDF, distribution of commercial traffic over the carriageway. So initial traffic is determined in terms of commercial vehicle per day, that is CVPD. For the structure design of the pavement only, commercial vehicles are considered assuming laden weight of these tons or more than their axle loading will be considered to estimate the initial daily average traffic flow for any road should be normally be based on 7 days or 24 hours classified traffic counts ADT. In case of new roads, traffic estimates can be made on the basis of potential land use and traffic on existing routes in the area. Traffic growth rate can be estimated by studying the past trend of traffic growth and by establishing anometric models. Inadequate data is not available. It is recommended that an average annual growth rate up to 7.5% may be adopted. The design life for the purpose of the pavement design life defined in terms of the cumulative number of standard axle that can be carried before the straightening of the pavement. It is necessary, and it is recommended that pavement for the artificial road like NH and SH, that is National Highway and State Highway, should be designed for the life of 15 years. The EH urban roads for 20 years and other category of roads for the 10 to 15 years. So vehicle damage factors, so that is called VDF. The vehicle damage factor VDF is a multiple of converting the number of commercial vehicle of different axle loads and the configuration to the number of standard axle load repetitions. It is defined as the equivalent number of standard axle per commercial vehicle. The VDF varies with the axle configuration, axle loading, terrain type of road, and the from region to region. The axle load equivalency factors are used to convert different axle load repetitions into the equivalent standard axle load repetitions. For the equivalency factors for IRC as per 37/2001, the exact VDF values may be arrived after the extensive field survey. The vehicle distribution, a realistic assessment of distribution of commercial traffic by the direction and by the lane is necessary, and it is directly affected the total equivalent standard axle load applications used in the design. Until reliable data is available for the following distribution may be assumed. Single lane road, traffic tends to be more channelized on the single roads than two lane road, and to allow for this concentration of wheel load repetitions, the design should be based on the total number of commercial vehicles in the both direction. Two lane single carriageway road, the design should be based on 75% of the commercial vehicle in the both direction. 4 lane single lane carriageway roads, the design should be based on 40% of the total number of commercial vehicles in both directions. Dual carriageway road, for the designs of dual 2 lane carriageway roads should be based on 75% number of commercial vehicles in each directions for the dual 3 lane carriageway, and dual 4 lane carriageway distribution factors will be 60% and 45% respectively.